All right. Do we now have sound? We have sound. What a concept. So let's start. Good afternoon, everyone. I'm Alan Holub. I will be around the conference for the rest of the week, so if you encounter me, please call me Alan. And my contact information is all up here also in case you need it for anything. I have a grand total of about 300 Twitter followers right now, so I don't know that that really counts for much. I was just converted to Twitter by one of my editors who put his foot down and he said, if you don't start tweeting stuff, I'm going to fire you. So I've started tweeting stuff as of about 3 weeks ago, which is why I have no followers, but I'm trying to be good. But feel free to send me some email if you have some questions or come and buttonhole me sometime during the conference. I'm happy to talk. Doing a talk like this is something of an exception to me, is that most of my work nowadays, at least, involves agile process in one sort or another, is that I do a lot of work where I'll come into a company and help them become more agile. I do a lot of software architecture work as well, just as a side effect of the agile side. In other words, I found that process and architecture are very tightly coupled to each other. And you can't really talk about process without talking about architecture, and you really can't talk about architecture without talking about process, as the two of them are connected. I do a lot of implementation. I'm working on a couple of startups right now, and I'm doing implementations for both of those startups. So the reason I'm competent to talk about these kind of technical subjects that the conference has me talking on is that I use this stuff all the time in the work that I'm doing. My general feeling towards speaking as an architect and process guy is that unless I'm also a programmer, nobody will take me seriously. And if you're not actually doing it, it's like, what right does anybody have to talk about it if you're not actually doing it? So I do it too. What we'll be talking about today is OAuth, which is the authentication mechanism that is mandated by Google and more is mandated by other of the online service organizations. We'll talk about, in a way, the order in which I'm doing these talks is a little off, is that I'm doing an introduction to cloud computing, at least looking specifically at Google and Amazon, I believe tomorrow. But I should have done that one first, really, because this is where you go once you make a decision about what platform you're going to move to. But we can talk about it in isolation, too. I'm going to bring up and demo one of the Google tools later on in the talk. At least I hope I will, if we have time for it. The main thing about OAuth is we've all probably used it. In fact, I know we've used it because the process that you went through to log on to the app for this application was OAuth. At least if you went through Facebook, or if you went through Google, or you went through LinkedIn, or any of the third-party sign-in processes, you were actually seeing the OAuth process in action. So OAuth is one of those things that we use a lot, and really all of your applications ought to be using it. So the real question then, oops, I thought I had this under control. Let's try that button. The real issue as to why you would want to use it then is that you're providing access to some third-party service of some sort. In the case of the application that we're all using, what we're doing really is providing access to the database that underlies the conference application. If we're talking about Google or Gmail or something like that, you might have a third-party application, and what you're doing with it is accessing something that is inside Google's computers. So for example, if you have a third-party mail application of some sort, Apple Mail is a case in point, or the Android native mail application, but you're using Gmail as your main mail server, then you need to access stuff that's on Google's computers. And in fact, Google is pretty good about OAuth as a way of accessing its services. Is that tomorrow in the cloud talk, I'll talk more about the kinds of services that Google makes available. But in general, it's everything. There are some annoying omissions. The to-do list, and for example, is not easily accessible through Google APIs, which drives me crazy because that's the one I want to actually access. But the vast majority of them, even the YouTube APIs, are available. So the question then is that if I'm going to have a third-party application that is going to be talking to Gmail, I really don't want to give it my Google password. Too much of my life depends on that. One of the big issues with respect to security is that there are certain accounts that you have online where security is more important than other accounts. And your email account is one of them. If you're not going to guard anything else diligently, you've got to guard your email account. I don't know if anyone remembers this, but a couple of years ago, somebody broke in. What happened is there was a journalist who should have known better, who had a 4-letter long Twitter handle. And a bunch of hackers wanted to get his Twitter handle, and they basically destroyed his life in the process of getting his Twitter handle. As they broke into his Apple account, and from his Apple account, they broke into other accounts. And in the process of doing that, they didn't want to leave a trail, so they erased every Apple device that he had because they were in his Find My iPhone cloud application, with which you can erase all iOS devices. And the point is that the point of vulnerability was his email account. Is what he did is he called up, I think it was Amazon, I don't remember, it might have been Apple itself, and said, I've lost my password, and managed to inveigle them to get into the email account for this guy. Once he was in the email account, he could log on to every other service that the guy belonged to and say, I forgot my password. And what do? They email you something. They'll either email you a new password, or they'll email you a way to get into the system to establish a new password or something. So if somebody's in your email account, they're in your life. They can get access to every online account you have through the password recovery mechanism. So guarding your email account, that's pretty important. And I'm certainly not going to give the password to my email account to some application on my iPhone that claims it needs to access Google data. I don't want to give it broad access to everything. So what OAuth does is it lets me grant access without giving up a password. The whole point of OAuth is that you don't actually have to give your password to the application in that case. And that's really important, to the point where I won't really use any application that requires my Google logon anymore if it asks for it directly, is that all of those applications must be using OAuth for me to be happy with them. So that's the point. Now, once you get in, then you have even finer control. In other words, OAuth really just talks about the process of granting permission. And it does this, we'll talk about this in a moment, but there are a lot of things missing from the standards, and one of them is the notion of fine-grained access. Every vendor gives you some kind of fine-grained access. As Google, for example, you can limit it to just Gmail. You can limit it to Gmail read-only. Right? In other words, you can narrow it down. It didn't used to be the case. 2 years ago, if you tried to use OAuth to get onto Google services, your options are, I give you access to my entire life on Google or nothing. Those were the only options, and they've gotten much more fine-grained from that. That's not actually part of the OAuth spec, though, which is one of the complaints that many people have about it, and I'll talk about that in a moment. The main idea, though, is to grant permission without giving up your password. So people think of this as a valet key. Right? The whole point of it is that we're trying to access the ignition but not the trunk, right? Is that you want to be able to get into the system and be able to do some things but not be able to do everything. And it's that limited access that's the important part of what OAuth is doing. All right, and I should say, by the way, with a group this small, when I give these kinds of talks, the only feedback I get is when people ask me questions. Not that I've said much that deserves a question yet. But please don't be shy about asking me questions, because otherwise I'm not going to have the feedback that I need, which is to say I will get more and more nervous, and I'll keep doing things like saying, does everyone get this? Does everyone get this? Right? And so in order to prevent me from looking like an idiot up here, you've got to ask me questions occasionally. So how does it basically work? There are 4 main players in what's called the OAuth dance. There is somebody who owns a resource. That's me. That's a human being. That's the guy who has the Google account, the Gmail account. There is an authorization server that is on Google, and typically there is a separate resource server. Now, there's no requirement that they actually be physically distinct machines. More often than not, they are, because both of them are pretty busy if it's a big service. But the only distinction between them is that they might have different URLs. And then you have some device that's running a client application, and typically it's nested like this, is that I've shown an iPhone here, but a web browser is just as good an example as an iPhone. The basic idea is that you have some application running in some environment that needs somehow to talk to get authorization and to access the resource. In order to do that, in order to get the access, there are a set of tokens, what are called tokens, which you could think of as things that are giving you permission to do something. OAuth has 3 of them that we care about. So I've only shown 1 here, but we'll talk about the other 3 in a moment. So the basic idea then is that you as a resource owner are giving permission to Google to grant access to the client, to allow the client to access the resource. And the important part of that sentence is that the resource owner is giving permission to Google, not to the client. Does everyone understand that distinction? That's the critical one. So at no point does the client need to know anything in terms of Google's authorization process. Now, OAuth has gone through a couple of variations. OAuth 1 was the original one, and I'll talk about this in a moment, but many people believe that we should still be using OAuth 1. OAuth 2 is kind of a mess. It's a giant can of worms. And in fact, the guy who invented OAuth 1 led the OAuth 2 standards committee for a couple of years, and he dropped out. He withdrew his name from the standard because he was so upset by what was going on. And the downside of OAuth 1 is that many organizations have chosen not to support it anymore. Google, for example, OAuth 1 is being phased out from Google. So we don't have any choice in spite of its problems, but it's worth thinking a little bit about OAuth 1 just simply because OAuth 2 comes from OAuth 1, so there's a lot of the same thinking in the system. Now, OAuth 1 involved a simple protocol, a simple flow, which I have demonstrated here. And we're going to see this picture in one variation or another several times, because OAuth, this is the core of the way OAuth is working. The basic idea here is that the user is visiting, you'll see at the top, a customer site of some sort. And the user wants to get data from some provider. So to do that, he grants permission. Right? Now, that yellow bubble is the important distinction between OAuth 1 and OAuth 2. In order to grant permission, you had to do a little bit of crypto. You had to get a token from the resource provider. You had to assemble another token, which was a fancy way of saying an elaborate URL. Then you had to digitally sign it. And digital signatures are a kind of encryption. I don't want to get too much into the underlying technology. But the basic idea is something called a one-way hash. The idea of this is that you take something and turn it into a number. But unlike a hash code that you might use in a data structure, a cryptographic hash is pretty much guaranteed to be unique. Given something that's book length, if you change as much as one letter in the book, you would expect about half of the numbers in the hash code to change. And you would also expect that no two books on the planet would hash to the same number. Or if they did, the protocols make it so that it doesn't matter, actually. But they don't. So hash codes are important, but you have to know how to do that. And in Java, for example, doing a cryptographic operation of any sort is enormously difficult. A lot of people complain about Java, and I think that's a misplaced complaint, is that Java is great. The libraries are some of the worst libraries I've ever encountered, but the language itself is fine. I have nothing against the language. And in fact, if you look at the way Java is being used nowadays, nobody's using the original Sun libraries, which is fine. May they rest in peace. Because that whole EJB thing was just a complete disaster. And I'm glad to see it go. On the other hand, the majority of web-based applications are still written in Java, in spite of the fact that people say that it's on the downside, is that the Java is still the language of the web, pretty much. So the problem, though, is that digital signing. So the idea was that in the original OAuth, when you pass a token back and forth between the grantor of permission, the resource manager in your own application, you would digitally sign it. You would do a little encryption in order to prove that you were who you said you were. And that's important. It turns out that a lot of the problems with OAuth 2 have to do with the fact that with OAuth 2 they said, nobody knows how to do digital signing. It's an enormous problem. So what we're going to do is we're going to throw out all of the cryptography that's part of the standard itself, and we're going to fall back to SSL, actually to TLS. So OAuth 2 requires TLS. Everything is an HTTPS connection. And it has to be HTTPS over TLS in order to be officially conforming to the OAuth standard. So the problem is that TLS doesn't actually grant some of the same, doesn't give you some of the same advantages that digital signing does. In other words, if it's digital signing, you're actually proving that you are who you say you are. TLS doesn't do that. Makes it so that somebody can't eavesdrop, at least not easily, but it doesn't guarantee that the person on the other end of the line is who they say they are. And it turns out a lot of the problems with OAuth 2 are exactly that. It stem from exactly that, which is why a lot of people think that you should still be using OAuth 1. So whether you want, I'm not going to say much about OAuth 1 because this is a talk about OAuth 2, but it's something to think about if you're going to be implementing it as compared to using it. You may want to think about implementing OAuth 1 rather than OAuth 2 for security reasons. If you're using it, we don't have any choice, as we pretty much have to use OAuth 2 for everything. So the OAuth 1 handshake, and again, this is very similar to the OAuth 2 one, so it's worth thinking about. There's a signing operation here. So the basic idea is that the web application requests an authorization from some consumer of the data. The consumer goes off to the service provider, and it gets what it calls a request token, which, as I said a moment ago, is just a fancy name for a URL, for a fancy URL. And then it digitally signed it, and then brought it back to the web application, which would then store it, or at least something would store it. It might store it locally inside the consumer. Later on, when the user goes to get permission, that token gets passed back over in order to get permission. And once permission is granted, then the request token is turned into an access token, and it's the access token that you actually use to access the data. Right, now, you don't have to follow this too closely because, again, this is OAuth 1. As I'm providing this just so that we can have some background here before we launch into the OAuth 2 flow, which I'll cover in a bit more depth. The main thing to notice here is that access token in OAuth 1 had an unlimited lifetime. This is one of the changes between OAuth 2 and OAuth 1. Once you got permission, you had permission forever. Now, you don't really have permission forever. Is that again, assuming that we have time, I want to show you how a couple of the OAuth tools work. But if you log on to Google, buried, unfortunately, deep down in your security settings for your Google account, there's a list of things that you have given permission to, entities that you have given permission to, and you can revoke permission at that point. Google, in its infinite wisdom, has made it difficult to find that page. It's buried inside the account information stuff that's, if you're on Gmail, you've got to go to your account first, and then you've got to go to the right tab, and then you've got to drill down from the right tab, and it's much harder to do than it should be. So that was another problem. And it's another problem that OAuth 2 is attempting to solve, and again, we'll look at that in a moment also. But permissions were held for much too long, as people could hold on to them for much too long a time. Okay? The other thing to notice in this picture is that there are a lot of redirects involved in order to make things work. In other words, if I'm going to ask permission from, effectively, I'm in a web application asking permission to Google. Is everyone understanding what I'm saying here? So in order to do that, I have to loop back around at the browser level. Right? This is always confusing to me. Every time I do this, I get confused all over again because the UI is in your browser, but you think of the work as going on the server, which is a different computer. So here is the server, effectively, your server, your web server, making a request to Google's servers to have access to Google information. But it's doing that by throwing onto your browser Google's login screen. So is everyone following me here? So the request authorization tag up there at the top, oh, my pointer's not working. But the request authorization tab up there at the top, let's see if I can get this to function. There it is, this guy. That is you talking to your own web server, your browser talking to your own web server, and then it talks to Google. So the question is, how does the Google get the UI displayed? And the answer is it returns this URL, which gets digitally signed, but then your web server is returning it back down to the browser as part of a redirect. So that's going to cause the browser then to go immediately down here and redirect out to Google to actually grant the permission. All right, I'm assuming that you know something about how redirects are working and HTTP works and that kind of stuff. Is everyone following me? So a redirect is a response. You make a request to the server gives you a response, and part of the header in that response says, this is not really the response yet, you have to go to this other place to get the response. And the browser then immediately bounces over there. Right? It may or may not show you where it's bouncing on the URL window up at the top of the browser, depending on how the header is set up. With OAuth, it should always be set up so it'll show you Google's URL, otherwise how could you trust it? That's something else, by the way, that you should think about when you're doing OAuth in your own applications, is your users are going to be much less sophisticated than you are. So be sure to make it very clear to them that this thing that looks like Google actually is Google. In other words, before you bounce over to Google, give them a little display, a pop-up or something that says, I'm about to take you to Google in order for you to grant permission. And then they can at least look up at the URL bar and see that it's a Google URL, and they look and it looks like a Google login page, and they'll be happy. If you don't say that, they'll think that they're being scammed somehow, that this is a phishing attack. Okay, is everyone following with me so far? All right, so along comes OAuth 2. OAuth 2 is meant to solve a couple of these problems: the long-livedness, if that's a word, of the access token, and the fact that people don't know how to do digital signing. Computer or programmers don't know how to do digital signing. So you have a limited lifetime. The basic notion of the limited lifetime is an important one, right? As access tokens fade out after a while, they have a limited lifetime. And they eventually can come back, but to do that, you have to give a second kind of token to the authorization server. So Google, as we'll see in a moment, all OAuth implementations have to give you 2 tokens when you make your original request. The user is still being redirected off to Google, but Google is going to reply with some kind of access token, but it's also going to reply with this refresh token. The access token, the original one, typically has about a 10-minute timeout on it. The standard is not, it doesn't make a hard number there. It doesn't give you a hard number. It's one of the complaints that people have about the standard, is that it doesn't give you a hard number. But the point is that you have 2 tokens now for access, which you didn't have before. Before you just had the 1. Okay? The other difference is that we're doing everything over TLS. Though that has its issues, is that there is no digital signing required, but because of the TLS aspect of OAuth 2, it is not backward compatible with OAuth 1. So if you've done work implementing OAuth 1, or you've done work doing implementing Handshake with OAuth 1, your work will not be valuable anymore, is that you have to redo things. And that's, I think, is a pretty significant downside. Is the architectures are similar, but they're not the same. All right, now all this sounds well and good, but in fact, it's not that good. The first problem is the security issue. I've given you a URL here for this very interesting IETF document. This is a document that was created by the OAuth committee. And you can see by its name that it's kind of scary. And in fact, it documents 52 known security vulnerabilities to OAuth 2. From my point of view, any standards committee that releases a standard that has 52 documented security flaws in it is just completely incompetent.
Is there an equivalent analysis for OAuth 1?
There isn't, because there was only one known security flaw, and it was fixed. So yes, there is an equivalent analysis. It's fine. That's the equivalent analysis, right? And so this is a big deal. At least it's a big deal for me. I really don't like this. Now, one of the things that this means is that if you're going to implement OAuth 2 as compared to just use it, you really have to know what you're doing from the security point of view. And you have got to study this document. I'm not going to dwell on a lot because it's kind of hardcore security stuff. But if you are not a security expert, you cannot implement OAuth 2 competently. It cannot be done. And don't imagine that you're a security expert just because you happen to know how to use the Java crypto APIs. Is that you need a real security guy in here doing this. So in practice, this hurts OAuth quite a bit. In other words, there are a bunch of issues here, but this makes the standard itself kind of very diffuse in the sense that a lot of the standard is open to interpretation. Right? If you read through the standard, in other words, there's a lot of things that aren't defined. As the OAuth token, for example, is not really defined. It says it's got to have this element and it's got to have that element, but it doesn't really tell you what exactly the elements have to look like. So among other things, that means that there's going to be variation from implementation to implementation amongst the providers. And that really annoys me. In other words, I can't implement OAuth sign-on once and have that work for both Google and Twitter, because they both have slightly different implementations of things. And that impacts the security issues again, right? Is that, in other words, I have no guarantee that every vendor that is supporting OAuth has actually solved those 52 security problems, plus the ones we don't know about. These are just the documented ones. Right? The zero-day ones are the ones that we really care about, but we don't know what those are, or they wouldn't be zero-day exploits. So there we are. OAuth 2 is very enterprise-focused, is that as compared to web-focused. OAuth 1 was almost entirely web-focused. And that's another complaint that a lot of people have about it, which I kind of agree with, is that there's been a lot of the standard has to do with writing enterprise apps that talk to other enterprise apps. And the fact is that nobody who's doing that is actually using OAuth 2, is that the standards committee got off on this weird tangent, and they put all of their efforts into that tangent, and they almost dropped the web side. And really, the web side, though, is the only side that matters. Oops. And then the interoperability issue that I just talked about is that you can't interoperate between Twitter OAuth and Google OAuth and Facebook OAuth. They're all slightly different. Now, fortunately, all of those guys provide us with some kind of library that we can use to talk to their systems. I should say the downside of that, though, is that you are now limited to how your application is put together because those libraries are not implemented in every known programming language. If you're programming in Java or C# or usually Python, and more now Ruby, you're OK. But if you're in any other language, it's iffy whether you can get a library that actually supports OAuth or not. And if you can get one, it's not being done by the vendor. It's not being done by Facebook itself, for example. It's being done by somebody else who's trying to support Facebook OAuth, and they may or may not have done it properly. So you have some limitations here. If you're not writing in one of the main languages, there are solutions to that problem that involve messaging. I'm doing a talk on messaging on RabbitMQ later on in the conference. So if you don't know about messaging, messaging is really a critical technology for any full-blown web application nowadays. So you need to learn about messaging. Rabbit just happens to be the messaging infrastructure that I use. There are many available. But it's a topic that you need to learn something about. So messaging can get you around this. So on the other side, though, Google requires it, so we really have to do it. The guy, as I said, who wrote the standard responded this way. I actually ripped this from his website. I didn't make this up. He has a long blog post, the URL of which I've given you on the bottom there, about why he thinks that OAuth 2 is awful. OAuth 2 went through 36 drafts. Which is also unbelievable. This process dragged out forever. And he pulled his name out after draft 31. He said, I've had it. And I think it was the fact that he pulled out that finally got the committee to start coming to its senses and doing some real work.
You said that, that Google requires it and therefore we have to deal with it.
Yeah.
That's mostly on the consumption side.
Yeah, but that's what most of us are doing. How many of us are going to be implementing OAuth? 2 of you. 3, and one maybe. Right? Most of us are going to be consuming. Most of us are going to be using OAuth. We have a client of some sort that needs to access Google data. That's what most of us are going to be doing. So the only people that really have to worry deeply about these problems are the people that are implementing OAuth. In other words, you're writing your own authorization server. And it's just tricky. It's just tricky. You know, I could go on for the entire session about flaws on the OAuth 2 standard. I don't want to waste your time by doing that. But you read through it, and it's infuriating. It's very badly written. The English is bad. And on top of everything else, though, it's very, they wouldn't make up their mind about anything. You can do it this way, or you can do it that way, or you can do it that way. And you know, you can make up something here. There's a few places where they say must, but not as many as I would like. So it's not really a standard. And in fact, by the time they got to the last draft, they had even stopped calling it a standard. They now call it a framework. It's the OAuth framework. It's not the OAuth standard anymore. So from the people who are, the point of view of people that are implementing it, it's really kind of a mess. So it's, well, it's a huge can of worms. I don't really want to delve into that too much because I want to talk about how to actually consume data using OAuth. OAuth 2 is just barely here. I don't know. I think probably not, because I think that from the vendor's point of view, they don't really care much about people who are implementing it. The big guys, right, Google and Facebook and stuff, all they care about is people getting access to the data. And since they've implemented OAuth 2 at this point, they don't really have much motivation for there to be an OAuth 3. Eventually, I think something's got to give. So it's an untenable situation as it stands now. But I don't know of an OAuth 3 committee that's active right now. Mm-hmm.
But I mean, a lot of the limitations come from Well, as you say, getting rid of the signature stuff, because that could easily be done.
Yeah, then those are kind of built in. A lot of those threat models have to do with the fact that the digital signing's gone. Yeah.
And one thing about crypto, maybe that will be available for JavaScript apps as well.
Well, there's nothing in OAuth. The problem is there's nothing in OAuth 2 that prevents you from using some kind of crypto to do signing. And some of the vendors do that. So, but that's not required by the standard, right? So it's not uniform across every OAuth 2 implementation. So we're back to using the vendor-supplied implementation. In other words, the way that you should, we'll look at both. I'm going to look at two of them. I'm going to look at Google's, and I'm going to look at Dropbox's OAuth implementation, just because it's so much better that it's nice to see a comparison. But the issue here is that it's very difficult to roll your own. You know, down at the URL HTTP level, where you're opening a socket connection and making an HTTP URL request to port 80, don't try it. There's just too much weirdness. It's just too hard. Okay? Is everyone following what I'm saying here? All right. So OAuth defines various flows. We're going to spend most of our time talking about the web server flow. I'll look at some of the others in a moment, though. But the basic idea of flows are ways in which OAuth can be used to do authentication, and the web flow is the main one because that's what most of us are going to be doing. The user agent flow is basically the same as the web flow, except it's happening inside a cell phone. That's the flow that was actually being used by the application if you logged on through your phone. The username password flow, that's kind of a what? Right? Because the whole point of this is to not provide a username and password, so why am I got an OAuth flow at all that has a username and password in it? The answer to that is this committee had this grandiose notion that there's going to be a front end that will handle all of the mechanics of various kinds of authentication. And that will all eventually funnel down to a token. And once you have a token, that's going to be standardized. And no matter how you initially arrived at that token, once you've got the token from that point forward, you can just do a token-based login, and you don't have to worry about any other kind of login. Good idea in theory. It doesn't work out that way in practice. And then there's an assertion one, which is even wackier, because that's just saying, I am who I say I am, I swear, I promise. And that's really good for nothing except in-house enterprise app to in-house enterprise app, where you can have some sort of key store that's a protected key store that's being used to get the assertions. And then finally, we have client credentials, which nobody does, right? Because nobody has a browser certificate that's got the client credentials on it. And you can only do this if the client itself owns the resource, right? So this is the picture we were looking at earlier without the web browser. It's just one server talking to another server. And again, you could argue, and the reason nobody does this really is there are better ways, right? If it's just two servers talking to each other securely, there are better ways, less complicated ways. So all these flows are defined in the standard, but in practice, the only one that we really care about is that web flow, which is why I'm going to spend most of my time talking about it. So let's look at the web flow. Basic idea here is that we start off at the web server, which I, the human being, the resource owner, is interacting with. I am going to request access, which is effectively a submit, right? There's some form sitting in my browser, and I hit the submit button, and off it goes to my server, right? So I'm on my web server at this point. The whole thing is the client. So as far as OAuth is concerned, it doesn't really say much of anything about what happens at the server level, and how you have redirects and how you're actually going to go out to the web service. All right, once I've requested access, then I can go out through a redirect to Google. So again, this is a redirect. My web server is replying back to the browser with a redirect which goes over to Google. At this point, Google can authorize me. In other words, this was a redirect to Google, so I am now looking at a web page that Google served, which is a login page of some sort. Okay? In the case of Google, it's multiple login pages, because the first time you go in, it's just a login page. Second time it goes in, it says, you know, this application is asking for permission to use these services. Is that okay? And then you say yes. Okay? Once permission is granted, it replies with an authorization code. which is typically stored on your web server. It's not, you should not send this down to the browser. Now, we have an authorization code, and we have to exchange it for those two tokens we were looking at a moment ago. There was my access token, and there was my refresh token. So that has to come from Google again, which it now sends back. But this has to be done by means of a redirect of some sort, because we're effectively getting back to your application at this point. So this is one of the security flaws in this system, is that these tokens are flowing through the browser, and I would argue that they shouldn't. Okay, but they have to because of the fact that there's a redirect involved. All right, is everyone following how this is happening so far? All right, so now I'm back looking at a page that was served from my web server. All right, is everyone with me here? I should also say, while we're looking at this picture, and we'll see another picture later on that makes it painfully obvious, but doing this in a pop-up is really hard. Because, in other words, if what you want is Google's page to appear in a pop-up, even if it's a pseudo pop-up, right, a JavaScript window that's been opened up, not a real second-level window, this redirect is going to redirect the contents of that iframe or whatever it was inside the pop-up. But there's no way back to the original page, right? You now have two pages displayed on the browser, but there's no way back from this one. So then there has to, you have to say to your user, click the X box on this other window to get rid of it, which is, from a UI point of view, an abomination. I would never recommend doing something like that. So you can't really do this in a pop-up, and at least not in a way that it gives you a UI that's acceptable. Okay? All right, now, at some point later, I need some resource. I'm doing something in my web application that needs some resource. And this, I'm showing this as coming from the browser, but it doesn't necessarily have to, is that it could just as easily be the web server itself that's requesting the resource. Right? So say that you were writing an application that was maintaining a couple of documents that were also being stored on Google. Or put it another way, let's say that you're using Dropbox as a way of storing stuff. But your application is going to be editing the thing, and you don't want to store it every time an edit happens. So in that kind of situation, the web server might go out to Dropbox and get the file. And then there'd be a lot of stuff going on back and forth between the browser while it's doing the editing. And then finally, you hit the save button, and then it goes back out to Dropbox and stores it, right? So the point is that the data is not necessarily going to be requested by the browser. It might be requested by the application itself. So I go to get the resource. I request the resource, passing it the access token. Right? Is everyone following me here? Now, one of two things can happen at this point. It could just return it. The data comes back. Everybody's happy. However, there's another situation, and that is that the token that we passed to it had timed out. So in that kind of situation, what we have to then do after the first step failed is a second step, which is now requesting a new access token using the refresh token. Is everyone following me here? So typically, the refresh token comes into play in response to a failure when you try and access the data. I would not suggest trying to actually keep track of the timeout values on the access tokens, because you don't know what they're going to be. It varies from vendor to vendor. So the downside of this is there's an extra round trip through the server. There's an extra HTTP call here in order to make this work. And this is a place where even the vendors are not happy with OAuth 2, because it's effectively doubling the load on their servers.
So you're saying refresh every time, don't worry about it?
No, what I'm saying is the way that you decide to refresh is that you try and request the resource, and it comes back with a failure, and then you refresh. So you don't want to refresh every time, because if the last request was within your 10-minute window or whatever it was, then you'll get the data, and you won't have to have that extra round trip through the server. But when the access token starts failing, then you've got to refresh. Right? So you've got to keep the refresh token forever on your server. It doesn't expire. But the access token does expire. Right? And again, you think about that for a minute and you go, what? If it never expires, then what have we accomplished here with all this craziness, right?
What have we accomplished?
Nothing. We have not accomplished anything of value. Is that I don't like this.
Keeping the refresh token secure is very important.
It's very important, right? But why don't you just keep the access token secure and get it over with, right? Is that what have we accomplished, really?
Is that not to be able to revoke access? Like you can revoke.
That's the theory. That was the theory. In other words, the theory was that you could revoke. Well, you could do this with OAuth 1. You could revoke access, and the way you did it was by looking at a revocation list. And what they found is that people who were implementing OAuth 1 were not bothering to look at the revocation lists. So the one thing that you do get out of this is that if you revoke both of these tokens, then you've effectively revoked access. But you could argue then, but still, you could just revoke the refresh token, right? In other words, all you've done here is put about a 10-minute window into this process that wasn't there before. And it hasn't accomplished much if you really kind of think out the whole handshake. So, you know, in other words, what's the difference between revoking an infinite access token and allowing the access token to have 10 more minutes of lifetime before you try and refresh it with a revoked refresh token, which doesn't work because it's been revoked?
What was the thinking behind doing?
I think they were just thinking that people aren't checking the revocation lists and that you want to be able to revoke in a more secure way. But I don't know. They just didn't think it out.
It looks pretty.
It looks pretty, yeah. But nobody likes this. Not even the committee likes it anymore. But it's in the standard. All right. Is everyone understanding how this handshake is all working? All right. So let's look at what some of this stuff kind of looks like under the covers. This is what an authorized request looks like. And as you can see, it's really just a long URL that's sent up, interestingly, as part of the HTTP header. But it's basically just a long URL. And there are a couple of things that are in that URL that are important. The first one is this notion of a client ID. And we'll look at that in a second. But a client ID is something that you get offline. So if you're going to provide access to Google services, in other words, you're writing a client that needs to access Google services, you have to open up a Google Apps account. And then you say to Google, in its configuration and its permission screens, I'm going to want to be using OAuth on the part of my own clients for them to access their data. Right? So Google at that point will issue you a client ID that is identifying your OAuth client. It's identifying the thing that is serving as the third party here, the thing that is going to be the third party that's going to be requesting the data of the actual resource owner. So that's got to be kept away from people as much as possible. Now, here again we have a potential security problem, but this is HTTPS. So the headers should be encrypted. But if you ever mistakenly send this request by HTTP, you've just given your client ID out to the world, and you're hosed. You're completely hosed at that point. So it's important to make that part of your test suite. This is always HTTPS. If it ever goes out HTTP, you're in deep trouble. All right, so everyone with me here. So the client ID is something that Google just gives you, and you have to include it in pretty much all of these requests. The other thing that I've pointed out here is that URI, that redirect URI, that's the place that Google is going to go to after it's done the authorization. Right? That's the landing page after you've done with all of the Google, does so-and-so have permission to access stuff.
That client ID is only required for, this is Google specific now, so if you're doing Dropbox, say, then...
Well, it'll have something like a client ID.
So does that mean if the Dropbox, the developer has to have a Dropbox account as well, and there'll be something similar?
Yes, the developer has to have a developer level account at Dropbox in order to get the ID. Yes, and that's the case with everybody. Everybody whose data you are going to be a third-party accessor of, you have to have an account with so you can get a client ID. Right? If you think about it, I probably should have put a slide that showed the screen up here. But when you log on to Google, what it says is Alan's app is asking for permission to do X. Well, where does that string Alan's app come from? And the answer is from the client ID. Okay, well, I did put the slide up there. I take it back. It's right down there in the bottom, right?
But the only protection against that getting spoofed is the fact that it's inside the TLS.
Yes. If this was not TLS, we would be hosed,
Okay.
right? Because otherwise it's going out in the clear,
Yeah.
right? And that really, the client ID really is a secret. You really want to keep it a secret. Okay, is everyone following me here? So the Google OAuth playground, again, if we have time, I think we'll have time. I'll bring it up and show it to you. But it is just a small OAuth application that Google has made available for free to play around with Google or with OAuth. And it's actually kind of nice, is that I would strongly recommend fooling around with it for half an hour before you try and do an OAuth implementation just to get a feel for how it works. Because it's basically the same flow, whether you're talking to Google or Dropbox or somebody else. It's always the same, but roughly the same flow. Okay? Now, at this point, the authorization server is going to send a response. And where it's sending it, right, the above here is the code that we were just looking at. And what's going to come back is this authorization code that's on the bottom. All right, is everyone with me here? So we've done that redirect. We're bouncing back around. We have an authorization code now. Now, the next thing you're going to remember, the authorization code is something that you trade for the access tokens. So this is the response. This is the thing that came back. So you take that authorization code, which I've circled there, and you pass it back to the response. I put it in red. So that code that came back in the authorization code is now going back out to request the tokens. That's the post. And what it's doing is it's requesting tokens. And what it returns is that little chunk of JSON on the bottom, which contains the access token, as you can see, and also the refresh token.
Sorry, Alan, can you just, I'm missing something. What's the point of having to go and request tokens? Why don't you just give me tokens on the first?
Well, remember, in the original OAuth, there was no refresh token. So the access token was the thing that you needed to actually do access. And the access token is revocable. Right? So the idea was that the people would actually hold on to the original authorization token for a while, or they could. And they got the access token immediately before they were getting access.
Sure. Why don't you just send back 2 tokens instead of the auth?
Oh, I don't know.
It seems like you've gained nothing again by just going.
By doing the double authentication. I think part of their thinking was that this way you could capture the authorization token at your web server level without ever bouncing back down to the browser level. Right? And at that point, you could have a hidden communication between your web server and Google servers that never bounced through the browser, so it would be more secure. I think that's what their thinking was. For some of the other flows, it makes more sense than it does with this flow. Okay, is everyone with me here?
Can I get this one? The first one is Google calling your web server as opposed to bouncing back from the browser.
Yes.
So basically Google being able to...
Well, it's going where it's redirecting, right? But where it redirects to is something, remember the very first one here had the URI to redirect to is encoded into the request. Right? The original authorization, well, that's another answer to the question, right? The original authorization request has the URI to bounce back to encoded into it. And that's not encoded in the access tokens. The access tokens are just tokens. There's no URI involved. Right? So that initial authorization, don't think of it as an authorization token, it's an authorization request. Right? And it had the URI in it. See, can I go backwards here? Yeah, see there's that URI in the request, which is where it's going to send the tokens. Right? And as I said, it's done with a redirect, but it could redirect to your server, right? It's not necessarily going to, you can redirect to anywhere you want, in other words. Okay?
One more question. What's the rest of that code bit before the red bit?
Oh, down here. This is all stuff that Google will. The answer is those are things that Google is generating in order to make things as secure as it can. And what's in here is up to Google, really. Right, is that the code here, maybe I just misdid it, right? The code that comes back, it starts with authorization code starts with the SXR. I may have a cut and paste error here.
I think before that
Oh, no, it's just me. Right, it's the whole thing should have been red. I just blew it. It's my fault. Okay. And the other thing to, oops, I keep going backwards, so I want to go forward, is that it will tell you how long it's going to hold on, how long the lifetime of the access token is going to be here. This is an expiration time for the refresh token. Some of the vendors will allow you to change that number, others won't. In other words, in your client account at the vendor, you might tell it how long you want it to be. I believe this, it's been a while since I've read it, but I believe the standard has an upward max on that at like half an hour or 45 minutes or something. But in general, you should just accept whatever timeout it gives you. It's just seconds here, obviously. Okay? Now we go to request some data. In this particular instance, I'm just doing it with curl from the command line just so that I can see what's going on. But so I'm asking for some data, in this case from the Blogger API set. Every service has its own specification about how you go about requesting data. But in this case, there is an OAuth flag, which takes as its argument the access token that came back on the previous slide. And that's generally the case how these are going to work, is you get an access token back, and then you've got to go request some data, and you pass in the access token. All right? And that's going to turn into a lower level request with the token moving across, and then you get some data back. And the data is typically, again, a big blob of JSON, this being the web that we're talking about. Again, the formatting of this blog, that's entirely up to the vendor. God knows what that's going to look like. All right, so everyone with me here? All right, so what if it's refused? Well, in that case, you have to make the request passing in a refresh token. And that request that was passed in the refresh token then is going to return some JSON that's got the access token in it. And then you back up a couple slides and re-request using the access token, the new access token. And notice that you do have an expires in with the new access token too, so you can track it if you want to. Okay, is everyone following me here?
Sorry, is it a sliding expiration?
I didn't hear you.
Is it a sliding expiration, or is it from the time when you make the initial request?
That's the expiration time from the point where the code was issued, which is going to be slightly different than when it's received, obviously, but not by more than a few seconds. And if you look at this code, you'll notice that, again, it's seconds, right? 3,600 seconds is an hour, so it's got a pretty long lifetime. But an hour is pretty generous, is that usually I see them down in the 10, 15-minute range.
When you're refreshing the token like this, is that client secret another name for a client ID that you have to
Yes. Yeah. Well, it's the client ID here, right? There's the client ID being passed in on the refresh request.
What is the client secret?
Hmm?
The client secret is the beginning of that line.
The client secret.
Is that person?
Well, the thing to the left here is the refresh token itself is fuzzed out.
No, the line above, sorry. What client?
Oh, this secret. One of the things that you can do as part of setting up the OAuth protocol is you can establish a secret with the OAuth provider. It's a completely arbitrary thing that you make up. And then they will send that client secret back down to you in order for you to make sure that these requests are coming from the right place. It's an equivalent would be with some banks when you go to log on, they like make you put a picture of your dog or something on the on the login page. And if people understood what this was for, it would be more reliable from a security point of view. But the idea is that if you see the page that comes from the bank that doesn't have the image on it that you picked, then you're being phished. Right? But unfortunately, users don't understand that, so it doesn't work very well. But hopefully, we will understand that. So this is just you saying, the secret is the secret I expect. Therefore, this thing is actually coming from the service I expect, because the service is the only thing that knows my secret.
Trying to replicate the signature on OAuth.
Yeah, they're trying to do the equivalent of digital signing in a less secure way. But again, this is a secret. If this is not flowing over HTTPS, we're hosed. So they're trying to duplicate the equivalent of digital signing. Okay? And then there's our data coming back. Or I'm going backwards again, aren't I? Right, so none of this is secure, as I said. Right? In terms of setting things up, we will look at the, actually we could look at the OAuth. I'll leave it up to you. I could actually show you this all happening live in the OAuth playground right now. Or I could move on and do the rest of the slides. Is that as we move towards the end of the slides, mostly what you're going to be seeing are examples that are online anyway if you want to look them up. So which is more important to you? I will let us vote on it. Is that who wants to see a live demo of this stuff? Anybody? Just 2 of you, 3 of you. So it seems like the vote is to move on. So I'm just going to move on. And if we have time at the end, I'll go back to the OAuth playground. But that OAuth playground URL at the bottom, that's an important one. Oh, and I should say these slides, I handed them in rather late to the conference. So I stuck them up on my website, too, if you don't have them in somewhere else. They're not on the memory stick, though they are on the conference website. But they're at holub.com/slides. So you can just download them. Where's the right remote? There it is. OK, but the OAuth playground basically allows us to do all of the things that we were just doing, except the OAuth client at that point is Google itself, right? It's kind of weird that a Google client is talking to Google via OAuth. But it makes the whole process transparent all the way down to the API call. So you can see things happening all the way down to the level where the API call actually happens. So it's nice. It's a good way to fool around with stuff. And I should say that I actually use the OAuth playground to make sense of the API calls sometimes, as some of the APIs are not very well documented. So the OAuth playground lets me actually send out an API call and see what the result is without having to mess around with curl and stuff. And it's sometimes easier to do it this way than it is to fool around with primitive tools, with more manual tools. All right, so there are a few additional flows that I want to talk about that are defined by OAuth. It's not things that we're going to do very often. The main one that you care about, which is, to my mind, it's like why even bother to call it another flow, is the installed application flow, which is what you would be using from your cell phone, but it's identical to the web flow. Right? The only difference is that the cell phone has to somehow be able to display the screen that is coming from Google. But the handshake is basically the same handshake as it was before. The one problem I have with this from a security point of view is that the cell phone application has got a little bit more access now than it would have if it was a browser thing. Right? If it's a browser thing, you're really completely isolated. If you're in a cell phone application, well, the host operating system has to be able to support Google's putting a screen up in the middle of your API, which is kind of iffy. Right? It may or may not be doing that. Right? As of course iOS and Android do it, but Android is always there are vendor variations, right? As you don't know which version of Android that you're using and that sort of thing. It's a constant problem. All right, but the new versions of Android handle it just fine. But the flow is identical. So there's nothing really to learn here in terms of the way OAuth itself works. It's just that the client will be implemented a little bit differently because it's running on a cell phone instead of in a browser, which I'm sure is not going to be an earth-shattering revelation to anybody here. The client-side JavaScript flow is a little bit different again. Notice that here a request token goes out. The one on the left is the standard web flow, the smaller one. The one on the left, a request token goes out, and then you, the user, are effectively logging into Google for the authorization code to come back. In the case of a JavaScript thing, the user, in a way, is kind of outside of the picture because it's all happening inside JavaScript on the browser. So you're still, in other words, going out and doing some kind of login and providing consent. But it's all happening inside JavaScript code, which has to be coded into the application. And what's actually coming back in this case is a token response of some sort. In other words, we're not doing this authorization code exchange thing anymore. is what's happening is a token is coming back to the JavaScript application. And then in order to use the token, you have to pass the token back up to the server who will then validate it and say, yeah, that's OK. So is everyone seeing the difference here in terms of the way that the handshake is happening? So the point of this is that this is something that could happen entirely inside JavaScript, inside your web application, without any UI stuff going on. At least not, in other words, these could all be AJAX calls. So the UI might not be updating as part of this.
How does the user log in and consent?
Well, that's the issue, right? A screen has to be put up somehow in order to make that work. So this would be JavaScript. This is a JSON kind of thing where I guess the assumption is that that's been done prior to the request. You know, as I said, these things are not used very often, and I haven't done this, so I don't know. It's that my own personal experience is all with web applications. And that's the vast majority of people I know are in the same situation. So I'm not even sure exactly why you would want to do this, to be honest. Is why would you want a JavaScript AJAX application to be doing this without using a UI, right? As you're on the browser, as you've got a UI. What's the problem? Limited input devices. Again, there's a flow for this. This would be a device that doesn't have much of a UI on it, but still has to get access to data for some reason or another. Some kind of home automation system, maybe, or something like that. Again, there's a similar kind of flow with this, again, user login and consent information flowing from God knows where. But this flow requires you to log on a different device with the browser. So you're allowing your Nest thermostat to put a log of all of the temperatures in your house into your Dropbox. Right? So all that this flow is about is it's saying, in order to keep things secure, we're going to force the user to go onto the browser for part of this process. So is everyone following what I'm saying? So part of the setup process would be going on to the browser.
And that works because the authorization code lasts forever.
That's right. And notice that underneath that, we're polling, right? Because the only way to find out when we're done with the browser, if we're sitting in the thermostat, is to poll the authorization server saying, has he done it yet? Has he done it yet? Has he done it yet? And eventually you'll get a response, we hope. Okay, so basically what's happening here is that the thermostat starts the process and then requires the user to go onto the browser and do the middle part of the process. And then you start polling the server saying, is the process complete yet? Is the process complete yet? Is the process complete yet? Service accounts, as we get further down, these are really just one server talking to another, and they become very simple at that point because there isn't a lot of outside stuff going on. It's basically just a simple handshake. Now, the one thing to have noticed with all of these is that eventually we end up with an access token. So the idea is that all of these flows handle the point up to where you got the access token, and then from that point down, it's all the same. That's the idea. So in theory, all the code you write from that point down can be the same. You don't care how you got to that point. It could be through any of these flows. Right, is everyone following me here? All right, now the next big issue that comes up when you're doing this is testing. So how do I test this stuff? Right, because Google's got to redirect to you. If you're on the other side of a corporate firewall, you can just forget it. It's not going to happen. Now, I fortunately work for startups, which means that I can walk over to the firewall and reconfigure it if I want to, right? Or log on to it and reconfigure it if I want to. Sometimes, if you talk really nicely, you can get somebody in your operations department to give you a hole in the firewall that you can use for those redirect requests. Right? You can have any port number you want. It's just a URL that you supply. But if you're going to test this stuff, and I mean really test it, you've got to get a hole poked in your firewall somehow for this to work. Because the only other alternative for testing, which is not a very good alternative, but I have done it in situations where I had no option, is I have logged on to Amazon EC2, rented a free virtual machine, right? Is it free for a year in the micro configuration? That's all that we need here. I've allowed my OAuth requests to respond to my EC2 machine, right? And then I've had it send me, in the case of the thing I'm doing here, I had to do it by email, actually, but send you in some way some kind of result. from the test to make sure that things worked, and then I had automated tests that pulled the email response out and dealt with it. And that was just an incredible kludge. I hate it. Is everyone understanding what I'm getting here, though? In other words, I'm getting around the fact that nobody in this idiot company was going to let me test the software that they had paid me to write. So the only way that I could do that was to set up my own server to be receiving these tokens so that I could make sure that I was getting the tokens that I expected to. So I was getting around their idiot security policies by, instead of poking a hole in the firewall, using email to make a jump around the firewall. Is everyone seeing what I was saying? So instead of going through the firewall to my test harness, it was going to this bogus computer that was then emailing into my test harness, which was then moving forward with the test. Right? And that was just wacky, but it was the only way that I could figure out how to do it. Now, if you have access to the router, though, as you can see here, it's way easier. This is the way that I usually set things up, is that I have an ISP modem that's feeding a router. And if you're going to be doing this in your own small office or you're going to be doing this at home, I strongly recommend that you never use the ISP's router stuff. Just use it as a pass-through modem. And then you can put your own firewall on the downside of it, and then you've got control. Is that if you're trying to use the modem that is, or the router that's supplied by your ISP, you may or may not have access to it. And if you do, it may or may not be documented correctly. So this way I can change ISPs, and I just swap the modem out with a new modem, and I'm done. I don't have to reconfigure my firewall. So I have a firewall behind it, which happens to be a wireless one. And what I did is that I set things up so that I could pull. I have a set of 4 static IPs on the modem. Right? So I've purposed one of those as the OAuth return, the 70.x. And then the wireless router is just running there normally, but it's turning into a local network. So I have 2 network connections on the box. I have the wireless network that I can use to look up documentation on the internet while I'm working, and at the same time, the OAuth responses can come back in the 70.2 address. And I'm depending on the fact that my laptop has 2 network connections on it. Another common variant on that, which I also set up when I need to, is that I'll have my firewall router. If your firewall router is supposed to support some kind of DMZ capability, that makes it even easier. Because now you've got one device, and you can do the route. You can actually do real routing up inside the firewall router to make it work. So typically what I'll do is I will take the OAuth return address, the 70.x.x.2 address, and I will use network address translation to turn that into something on the LAN. So does everyone see what I'm doing here? So the 70.2 is just mapped then to the 192.168.3.10 on the left, right? So that's the local address for the incoming OAuth request, and then the thing on the right is just my normal wireless router, which is using DHCP to assign address. Right, so that's better. But so if you don't know how to configure your router, you're going to become friends with your routers. You've got to right. You need some kind of firewall thing set up to make this work properly. All right. Is everyone following what I'm getting at here? Okay. So let's look at some of the implementations here. In particular, I'm going to be looking at the Google ones. I've given you the URL here for Google's OAuth documentation, which is not bad. So it's a good way to get more information than what I'm talking about here in class today. Google supplies APIs for all of these languages, which are not every language on the planet, but it's a goodly collection of them. It also supports Go for what that's worth. Google is doing weird things with languages, as they keep trying to push languages on us, and nobody wants them, but they keep pushing them nonetheless. They're up to 3 at this point. But it supports all the standard web languages at least. So if you're going to be talking to Google using any of these platforms, then the reason it's supporting JS is for JavaScript rather is if you're using Node.js as your server, right? Is that Node.js has gotten very popular in the Bay Area at least as a web server replacement. So that way you have a JavaScript library that you can use in Node, and it works fine. Okay, but it will also work with client-side stuff. There's also a developer's console, which is something that you're going to have to get into. I'll look at a couple of the examples in a moment. But this is how you're going to do things like set up your client secrets. Right? It's how to set up this, and this is also how you're going to get your client ID from Google. So you log, once you get your Google Apps account, you go get a Google Apps account, you go to, what is it, apps.google.com and get an account if you don't have one. It's free. And then you go to the developer console and you'll see a window that looks something like this. And notice that there are a bunch of things, there's a bunch of things on here, not all of which are relevant. But notice that you have lists of APIs, and on this first screen what you're doing is telling the developer console which APIs you're actually going to be accessing using OAuth and the underlying API. Right? So if somebody tries to access any of the other Google APIs claiming to be you and you don't have it turned on in your console, Google will reject the request. So this is a little bit more extra security, and it's a good thing to have. Do not turn on all of them on the theory that you should have them all on. Right? Is that you should only turn on the ones that you actually intend to access. The next screen is the way that you create your client IDs. Right? So I'm not going through the whole process, but basically you say create new client ID and it makes one for you, which you then have to stash away someplace. Right? Don't publish it. So you click the client ID button and that's how you get your client ID. When you do API access, you also have to have an authorization key to access the individual APIs. So that's what that second thing is for. This is not a class on the GData API, so I'm not going to dwell on that. But it's the same page that you get the authorization key from. Don't confuse the client ID, which is an OAuth thing, with the API access, which is just a Google Data API thing. Next order of business is that you can control, to some extent, what the consent screen looks like. So-and-so is, this application is asking for permission to use this particular, to access this data. And as you can see, it's kind of gray there, so it's a little hard to see. But this is the default, right? This app would like to do something. Right? Is everyone seeing where I'm pointing? So you can customize that, right? As you can add a little bit of text of your own and remove text and that kind of stuff. And then finally, you can establish the domains from which the requests are coming. And that's also an important kind of adjunct from the security point of view. Right? In other words, it's saying that OAuth requests must come from my web server. See what I'm saying? If I'm allowing Holub.com to access Jules's Google data, that request has to come from Holub.com or it's going to reject it. Is everyone following what I'm getting at here? So that's another kind of adjunct, a security adjunct, that makes things a little bit more secure than you can get from the standard itself. And then we have all of these various APIs that you can then, or you can use to look at stuff. You can basically, these are things that Google has added to the specification in order to make it secure. I'm not going to dwell on this. Mostly what I wanted to do was just show you the length of this list. So this is all stuff that was not covered by the standard that Google thought should have been covered by the standard that it added. Every vendor will have a separate way of doing things. Okay? Now let's look at the APIs. I'm looking at the Java ones here just because they're characteristic. The C# ones look almost identical to the Java ones. The basic strategy is that you are providing a servlet, right? In Java, how many of you are familiar with Java servlets? Just so I know what I need to talk about. Anybody? The basic idea, it's the equivalent of a service in .NET. It's the basic idea is that a servlet is a little class whose methods get called as a side effect of an HTTP request coming in. So basically the way that you deploy an application on a server that's running Java is you deploy this servlet, and when somebody makes a GET request to the server, the doGET method of the servlet is called. So it's basically a callback. And then there's a doPost also, which does the same thing, but in the case of OAuth, almost everything is GET. All right, so there is a doGET, which in this case is not doing much of anything because in this particular this particular example, it shouldn't, right? Notice that what we're extending here is abstract authorization code servlet. So most of the work of implementing OAuth is actually being done in that base class implementation of the servlet. Right? And the get is provided down here in case you wanted to do anything with it, but as I said, you're not, right? The get redirect URIs, right? These are all overrides of methods that are defined up at the base class level. So if any of you know design patterns, this is an example of the template method design pattern. The basic idea of template method is work goes on at the base class level, but there are a few things that the base class doesn't know enough to be able to do. So the most sound way to do that from a maintenance point of view is rather than trying to move the actual work down to the derived class, you just provide some hooks. And when the base class needs something to happen that it can't do, it pulls up that operation from the derived class level. So that's what we're seeing here, is that the redirect URI, for example. Remember when we were looking at the code earlier, as part of that OAuth handshake, you have to provide a redirect URI that is where the redirect is going to go to once the authorization code is issued. So this base class can't do that because it doesn't know anything about you, right? It's just a generic base class, so this is how it gets the URI to insert into the request in the right place. Is everyone following with me? Following me here. Now, Google's implementation is actually quite good in that it implements all of the OAuth flows that we were looking at. Not all implementations implement all flows. Google's does. So the initialized flow is the way that you're telling the base class which authorization flow that you're using. Normally, it's going to be the web flow. Right? Your client secret and your client ID, those are coming from the pages that we were just looking at when you were logging onto your account and getting that information. Right? So this is stuff that's a side effect of setting your account up. Actually, I should have shown you on the screen, but the client secret, when you set up the ID, it asks you whether you want to establish a secret or not. You can set it up on the same page. All right, is everyone with me here? User ID, same thing. Most of these work about the same way. Right, and then there's an on success and an on error, and I think from this point on you can kind of see how they work, right? If there's a success, you get to on success. If there's an error, you get to on error, as you can decide what you want to do in those situations. More often than not, you're not going to interrupt the flow, but you're going to log something. All right, and then there's the get redirect URI for part of it. Anyway, this is the same slide done over again. I did something wrong with the automation. Is everyone understanding how this is working, though? So this is basically Google's way of doing this, is that it's doing most of the work at the base class level. It's providing a few callbacks down below that you can use to provide those chunks of the service that you need in order to get work done. Now, just for contrast, I thought I would throw in Dropbox's APIs, because Dropbox uses a completely different system. Right, as here we are back in the land of confusion that we get when we don't have real standards. But it's actually not bad. It's that I think it's a little bit better than the Google one, to be honest. It's cleaner, certainly. So the basic idea here is that this is all just done with a few methods, as there are no classes involved. It's all just sort of basic method calls. This is all, remember, server-side methods or client-side methods, depending on what we're doing, but here it's a server. Right? We just have, again, a Java application running. It's got main in it. It's got an app key and a secret. The same key and the secret that came from Google, you're going to get from Dropbox, in this case, rather than getting from Google. You have to give it that information. That's the DBX app info class. I'm not responsible for these names, so do not blame them on me. Then you configure the system. So we're configuring the system by telling us what our application, we're telling Dropbox basically what the name of our application is. In this case, it's a tutorial that I grabbed off the Dropbox site, which is why it's the Java tutorial /1. I'm setting up the authorization information underneath, right, for doing redirection. And more to the point, here's the real work, which is WebAuth start. And following that, in this case, is just going to system.out rather than generating a web page. So here it's asking for the username and the password, right? It's just going to system.out to ask for the username and the password, and then I'll type in my username and my password, and it'll come back in. If this were a real web application, you would do a redirect here to a generated page that requested the username and the password. And then when you're finally done down at the bottom of it, you're reading things back in. You're going to the authorization system and getting your access code. And then we finally have this DBX client thing, which is how you make all of the calls into the Dropbox APIs. Right? So here, for example, is downloading a file from Dropbox. So I like these better than Google's just because they're cleaner. There's less work involved. And one of the reasons I wanted to show you this is that I hear a lot of complaints about Java, which really shouldn't be complaints about Java. I said this earlier, I'll repeat myself. There are complaints about the really badly conceived interfaces that always seem to surround Java applications for some reason. There's some disease that Java programmers have that makes them want to do things in the most complicated way possible. And the reason I'm kind of throwing up the Dropbox APIs is because, well, this is Java, but it's nice, it's clean, it's simple, it gets the job done, so I'm happy. Okay, so I'll finish up with a few URLs. These are the URLs for the OAuth specs themselves, if you want to read it, the URL for the threat model. And then down underneath here is a URL for another site entirely, but they've got implementations of OAuth for 15 or 20 different platforms. So in terms of getting some more information about how to talk to Facebook or how to talk to whoever, this is actually a really good resource because these are working examples that actually use the APIs of the various vendors to get work done.
What's the point of if each vendor's providing you their own client library and the underlying protocol is irrelevant?
Yeah, in a way it is. And the standard has forced us in that direction. But I guess my objection is that I don't want it to be irrelevant. In other words, what I'd like to do is set up OAuth for Google and have my OAuth authenticator work just fine on Facebook. Why should I have to have two of them? Why should I have to have this giant switch statement that says, if you are going through Facebook, use this system. Otherwise, if you're going through LinkedIn, use this system. Otherwise, if you're going through Google, use this system. It's like, give me a break. I want to do it once and get it over with. And they've forced us basically, there's a standard, but as you can see, there's not really a standard because we can't code to it. It's too loose. And there was that long list of Google stuff that they've added in order to make it secure in their mind. Right, so it's a problem. But anyway, here are all the various specifications. So according to that clock, is that clock right or is my watch right? Is that I can show you the live demo if you want me to, right? I have 7 minutes. Is that correct, more or less? Yeah, we have a couple minutes. Let me just do it. It does not take long, and it's instructive, I think, to watch it happen. Get a browser over here. Let's get a browser over here. It's going to let me do it. You could, there's parts of TLS supports a client-side cert. So you could do authentication using the client-side cert stuff. It's just that most TLS implementations don't use it. The browsers don't in particular.
I was just thinking more along the lines of, you're saying it's hard to get server-side right if you're writing your own server.
Yeah.
As a user of Google stuff, is there anything you can screw it up apart from not making sure you've got the encryption?
That's the only thing you can do wrong.
Right.
As long as you're using the Google APIs and you've got HTTPS everywhere on all URLs, you're fine. Okay, so here, let me go over to the OAuth toolbox. So this is just the playground. The first step is that it wants me to select the APIs that I'm going to be talking to. So I'll do that here. I'll do that if it's going to let me. Why is it not letting me? It's not letting me scroll. Hello. I shouldn't have maximized this window as my scroll bars are off the edge of the screen. And now I can't, well, here. It's not letting me minimize. I'm doomed. Let's do this again, sorry. I'm going to do this the easy way. And it's maximized again. It is not making my life. This is going to be too much screwing around. Is that we can. Should I give up? We have 5 minutes. I'm likely to spend the next 5 minutes screwing around with the browser, trying to get it to behave itself. But the basic idea is, well, we have 3 APIs here. Why don't I just pick one? Is let's say that we were going to the Exchange APIs, right? Is that I can say to it that I'm going to be using these APIs in my authorization request, right? Step 2 is that I want to exchange them for tokens. So I want to make the authorization request up here, right? So I don't have a scope that I care about, so I'm going to do the authorization. And there is the screen requesting the authorization. So this is the same screen that you would see on the redirect when you were going through the standard process. I will accept it, which is to say I'm giving it permission. And now it redirects back. And here it's showing me the response that I got back from Google. So I see the whole token that it generated. I see that it's coming from the OAuth playground. If I could scroll, I could show you the stuff to the right. But you get the general idea of what I'm doing here. You can actually see what the response is. I can then do the exchange. So again, I would normally have to pull the token out of here and then send it back in a round trip in order to get the exchange. It will do that for me. So here's the authorization code that was embedded inside this response. Right? So I can then ask for the exchange, and then there are the refresh tokens and the access tokens that came back, and here is the HTTP stuff that came back. Is everyone following me here? So now we're in the level where I can actually make an API call. So it will fortunately let me pick it here, so I don't really even need to know much about what I'm accessing. But let's get some accounts. Right, so this is what it's done here now is it's generated a request. It's probably going to fail because I don't have a valid ID here. But then I can send the request, and then I get the response back here, which is, as you can see, is an error because I didn't have a valid ID. So this basically lets you walk through the whole process of not just getting the OAuth authentication and seeing all of the back and forth as you move through it, but it's also allowing you to make an API call and see what the response to the API call is, which, as I said, with some of these APIs is pretty handy, is that some of them have holes in their documentation. All right, if you're going to be fooling around with the APIs without this, you'll have to do this anyway in order to get that OAuth authorization key in order to make the call, right? So at some point, you've got to be in here. Okay, so my advice is to just go up to the Google website, and the URL was in the previous slide, and just fool around with it. Just spend 20 minutes fooling around with it. Just set up a Google account, and if you don't have one yet, get a Google Apps account, set up the OAuth stuff that we saw earlier, and then fool around with the workbench here. Okay?
The original authorization token you get, that's good forever. So presumably you can use that to identify the user.
No, the authorization key is not good forever. That original authorization request that you exchange for the tokens has a 10-minute lifetime on it usually.
No, sorry, the very first one, right at the beginning. I've forgotten the name.
Very first. Well, the first one up here, well, it's not going to go back, but the authorization basically the authorization code is translating your client ID into a one-time authorization code.
That's right.
It can be used exactly once, and it times out. So thereafter, you've got your tokens, which is what came back when we did the exchange.
The authorization code gets used once.
The authorization code you can only use once usually. Yeah. And then from that point, you've got your refresh token, which is effectively replacing the authorization code in terms of what you're thinking. Right? The authorization code is a way to get the redirect URI to Google, basically. Once you've got that, once you have your token, you don't need all that redirect UI stuff because you've granted permission. You're trying to separate the permission granting process from the data accessing process.
Okay, let me ask the question from the other side. At some point, you've now gained access to a bunch of assets belonging to some user, but you need to know who that user is in your terms. So you need like a user ID, which you can use. That's all
encrypted in the authorization code, basically.
But you said that
Or not in the authorization code, in the access token.
Right.
The user's the access token is unique per user. Right? You can't use this access token to access a different user's account on Google. You can only use it to access the account of the guy that just gave you permission. So there's information in both the refresh token and the refresh or the authorization code that allows Google to know whose data you're accessing.
So next time he logs on, does he get the same authorization code come back with a different one?
No. The authorization comes back when you grant Google access to the data. That happens once.
Right.
And from that point on, your application should never have to go through that OAuth process again because you've granted access. The only time you can withdraw the access, I can't get at the browser. If I went into my account settings, you would see that the OAuth 2 Playground is now listed as an OAuth application to whom I have granted access, and I can revoke it. But that's the only reason you would ever have to go through this process again, is that if you revoke it or if your server crashes in some way that kills the code.
So when my user shuts down his browser, goes to sleep, comes back tomorrow, and then asks for wants to log in again.
They'll be using the refresh token or the access token, which is stored on your web server.
I see.
Well, it's in there. That weird string somehow has got a user ID encrypted into it.
But within your world, you would...
Oh, and in my world, I have to associate it with the user. Yeah, it's part of my user object in the database has got to have these tokens stored in it.
Which one of
Yes.
those do you associate with the user in your world?
Both.
Okay.
Right, because you'll need the refresh token occasionally when the access token stops working.
Right.
Right, so the refresh token has to be stored, and I would strongly recommend storing it encrypted. So treat it like a credit card number.
Yes.
Right? The access token, well, it'll time out after a while, but you might as well encrypt it. But the refresh token is the critical one.
Okay.
Right, so
Now,
treat
I
it.
also saw in the console there were quotas there for how many requests you could make. Isn't this way back?
Yeah.
How important is that? Can you lift those quotas?
So what?
Can you lift those quotas?
Probably. I've never had to, but probably. I don't know. It says that quota thing is going to vary again from provider to provider. Oh, notice that it's also counting down my access time here.
No, I think that depends on the business model of your server as well. I think
Yeah.
you to charge for 1,000 notifications.
Yeah, it varies. Google tends to limit stuff a little bit more than other services do, as they're a little more serious about restricting resources. Okay, anything else? We're actually out of time by about 5 minutes now, but I'll be around here to answer questions if you have more questions. And I'm happy to hang out right here until the next guy comes, so you don't have to leave. But I'm giving you permission to if you want to, if you have no more questions. All right. Do we now have sound? We have sound. What a concept. So let's start. Good afternoon, everyone. I'm Alan Holub. I will be around the conference for the rest of the week, so if you encounter me, please call me Alan. And my contact information is all up here also in case you need it for anything. I have a grand total of about 300 Twitter followers right now, so I don't know that really counts for much. I was just converted to Twitter by one of my editors, who put his foot down and he said, if you don't start tweeting stuff, I'm going to fire you. So I've started tweeting stuff as of about 3 weeks ago, which is why I have no followers, but I'm trying to be good. But feel free to send me some email if you have some questions, or come and buttonhole me sometime during the conference. I'm happy to talk. Doing a talk like this is something of an exception to me, is that most of my work nowadays, at least, involves agile process in one sort or another. Is that I do a lot of work where I'll come into a company and help them become more agile. I do a lot of software architecture work as well, just as a side effect of the agile side. In other words, I found that process and architecture are very tightly coupled to each other. And you can't really talk about process without talking about architecture. And you really can't talk about architecture without talking about process, as the two of them are connected. I do a lot of implementation. I'm working on a couple of startups right now, and I'm doing implementations for both of those startups. So the reason I'm competent to talk about these kind of technical subjects that the conference has me talking on is that I use this stuff all the time in the work that I'm doing. My general feeling towards speaking as an architect and process guy is that unless I'm also a programmer, nobody will take me seriously. And you know, if you're not actually doing it, it's like, what right does anybody have to talk about it if you're not actually doing it? So I do it too. What we'll be talking about today is OAuth, which is the authentication mechanism that is mandated by Google and more is mandated by other of the online service organizations. We'll talk about, in a way, the order in which I'm doing these talks is a little off, is that I'm doing an introduction to cloud computing, at least looking specifically at Google and Amazon. I believe password. Too much of my life depends on that. One of the big issues with respect to security is that there are certain accounts that you have online where security is more important than other accounts. And your email account is one of them. If you're not going to guard anything else diligently, you've got to guard your email account. I don't know if anyone remembers this, but a couple of years ago, somebody broke in. What happened is there was a journalist who should have known better, who had a 4-letter long Twitter handle, and a bunch of hackers wanted to get his Twitter handle, and they basically destroyed his life in the process of getting his Twitter handle. As they broke into his Apple account, and from his Apple account, they broke into other accounts. And in the process of doing that, they didn't want to leave a trail, so they erased every Apple device that he had because they were in his Find My iPhone cloud application, with which you can erase all iOS devices. And the point is that the point of vulnerability was his email account. Is what he did is he called up, I think it was Amazon, I don't remember, it might have been Apple itself, and said, I've lost my password, and managed to inveigle them to get into the email account for this guy. Once he was in the email account, he could log on to every other service that the guy belonged to and say, I forgot my password. And what do? They email you something. They'll either email you a new password, or they'll email you a way to get into the system to establish a new password or something. So if somebody's in your email account, they're in your life. They can get access to every online account you have through the password recovery mechanism. So guarding your email account, that's pretty important. And I'm certainly not going to give the password to my email account to some application on my iPhone that claims it needs to access Google data. I don't want to give it broad access to everything. So what OAuth does is it lets me grant access without giving up a password. The whole point of OAuth is that you don't actually have to give your password to the application in that case. And that's really important, to the point where I won't really use any application that requires my Google logon anymore if it asks for it directly, is that all of those applications must be using OAuth for me to be happy with them. So that's the point. Now, once you get in, then you have even finer control. In other words, OAuth really just talks about the process of granting permission. And it does this, we'll talk about this in a moment, but there are a lot of things missing from the standards, and one of them is the notion of fine-grained access. Every vendor gives you some kind of fine-grained access. As Google, for example, you can limit it to just Gmail. You can limit it to Gmail read-only. Right? In other words, you can narrow it down. It didn't used to be the case. 2 years ago, if you tried to use OAuth to get onto Google services, your options are, I give you access to my entire life on Google or nothing. Those were the only options, and they've gotten much more fine-grained from that. That's not actually part of the OAuth spec, though, which is one of the complaints that many people have about it, and I'll talk about that in a moment. The main idea, though, is to grant permission without giving up your password. So people think of this as a valet key. Right? The whole point of it is that we're trying to access the ignition but not the trunk, right? Is that you want to be able to get into the system and be able to do some things but not be able to do everything. And it's that limited access that's the important part of what OAuth is doing. All right, and I should say, by the way, with a group this small, when I give these kinds of talks, the only feedback I get is when people ask me questions. Not that I've said much that deserves a question yet. But please don't be shy about asking me questions, because otherwise I'm not going to have the feedback that I need, which is to say I will get more and more nervous, and I'll keep doing things like saying, does everyone get this? Does everyone get this? Right? And so in order to prevent me from looking like an idiot up here, you've got to ask me questions occasionally. So how does it basically work? There are 4 main players in what's called the OAuth dance. There is somebody who owns a resource. That's me. That's a human being. That's the guy who has the Google account, the Gmail account. There is an authorization server that is on Google. And typically, there is a separate resource server. Now, there's no requirement that they actually be physically distinct machines. More often than not, they are, because both of them are pretty busy if it's a big service. But the only distinction between them is that they might have different URLs. And then you have some device that's running a client application. And typically, it's nested like this, is that I've shown an iPhone here, but a web browser is just as good an example as an iPhone. The basic idea is that you have some application running in some environment that needs somehow to talk to get authorization and to access the resource. In order to do that, in order to get the access, there are a set of tokens, what are called tokens, which you could think of as things that are giving you permission to do something. OAuth has 3 of them that we care about. So I've only shown 1 here, but we'll talk about the other 3 in a moment. So the basic idea then is that you as a resource owner are giving permission to Google to grant access to the client, to allow the client to access the resource. And the important part of that sentence is that the resource owner is giving permission to Google, not to the client. Does everyone understand that distinction? That's the critical one. So at no point does the client need to know anything in terms of Google's authorization process. Now, OAuth has gone through a couple of variations. OAuth 1 was the original one, and I'll talk about this in a moment, but many people believe that we should still be using OAuth 1. OAuth 2 is kind of a mess. It's a giant can of worms. And in fact, the guy who invented OAuth 1 led the OAuth 2 standards committee for a couple of years, and he dropped out. He withdrew his name from the standard because he was so upset by what was going on. And the downside of OAuth 1 is that many organizations have chosen not to support it anymore. Google, for example, as OAuth 1 is being phased out from Google. So we don't have any choice in spite of its problems, but it's worth thinking a little bit about OAuth 1 just simply because OAuth 2 comes from OAuth 1, so there's a lot of the same thinking in the system. Now, OAuth 1 involved a simple protocol, a simple flow, which I have demonstrated here. And we're going to see this picture in one variation or another several times, because OAuth, this is the call. Leave tomorrow, but I should have done that one first, really, because this is where you go once you make a decision about what platform you're going to move to. But we can talk about it in isolation too. I'm going to bring up and demo one of the Google tools later on in the talk. At least I hope I will, if we have time for it. The main thing about OAuth is we've all probably used it. In fact, I know we've used it because the process that you went through to log on to the app for this application was OAuth. At least if you went through Facebook, or if you went through Google, or you went through LinkedIn, or any of the third-party sign-in processes, you were actually seeing the OAuth process in action. So OAuth is one of those things that we use a lot, and really all of your applications ought to be using it. So the real question then, oops, I thought I had this under control. Let's try that button. The real issue as to why you would want to use it then is that you're providing access to some third-party service of some sort. In the case of the application that we're all using, what we're doing really is providing access to the database that underlies the conference application. If we're talking about Google or Gmail or something like that, you might have a third-party application, and what you're doing with it is accessing something that is inside Google's computers. So for example, if you have a third-party mail application of some sort, Apple Mail is a case in point, or the Android native mail application, but you're using Gmail as your as your main mail server, then you need to access stuff that's on Google's computers. And in fact, Google is pretty good about OAuth as a way of accessing its services. Is that tomorrow in the cloud talk, I'll talk more about the kinds of services that Google makes available. But in general, it's everything. There are some annoying omissions. The to-do list, and for example, is not easily accessible through Google APIs, which drives me crazy because that's the one I want to actually access. But the vast majority of them, even the YouTube APIs, are available. So the question then is that if I'm going to have a third-party application that is going to be talking to Gmail, I really don't want to give it my Google